Angles are formed when two intersecting lines or surfaces meet at a common point or vertex. There are many ways to classify angles based on their measurements, and in this video we are going to focus on angle theorems. We'll start with some basic angle relationships and properties, and then look at the relationship between angles formed between parallel lines. So let's start with supplementary angles. Supplementary angles are two angles that when added together have a sum of 180 degrees. So for example, if you have a straight line and on that straight line you have another arm branching out, you will actually create two different angles. Two angles that are found along a straight line will always add up to 180 degrees. So in this example here, we're asked to determine the angle CBD. So angles are typically referenced by three letters. And so to locate angle CBD on this diagram, we just have to look for the letters in that order. So we've got C, B, and D. So the angle that they're actually referencing is this corner angle here. So the letter that shows up in the middle of those three letters is typically the angle that you're looking for. So if we're looking for angle CBD, we're looking for the angle that is directly beside this 140 degree angle. So because we've got two side-by-side angles that are found on a straight line, we know that these two angles together must add up to 180 degrees. So knowing that, I can just do a simple subtraction. So we're going to subtract 180 degrees minus 140 degrees. By subtracting, that's going to give me this angle that is left over. So 180 minus 140 would be 40 degrees. So I know that this angle here is going to be 40 degrees. Another simple angle property or relationship is complementary angles. Complementary angles are two angles that when added together have a sum of 90 degrees. So before we talk about how to calculate a complementary angle, let's just remember that a 90-degree angle also is called a right angle. So it is a kind of L-shaped looking diagram that is marked with a little square in the corner. And seeing that square marked in the corner tells you without a doubt that that angle is 90 degrees. If you were to see an angle and that little square is not marked in the corner, you cannot assume that that angle is 90 degrees. It might visually look like a right angle, 90-degree angle, but unless you get formal confirmation with that little square, you shouldn't make the assumption that that is a 90-degree angle. So in our example here, we're asked to determine the angle X. So that is the angle in our diagram that is marked with a lowercase x. Now, again, we can see here that we have a 90-degree angle or a right angle. I know that for certain because there is a little square, this blue square here marked in the corner. That tells me for sure that this entire angle is 90 degrees. However, my 90-degree angle has been split into two by adding this extra arm. And so I know that this angle here is 62 degrees. And we're just asked to figure out what this missing angle is. I know that together, these two angles are going to add up to 90 degrees. So to find angle X, we're again going to just perform a very simple subtraction. I'm going to take 90 degrees and subtract 62 degrees from it to get my leftover angle X. And 90 minus 62 would give me an angle that is 28 degrees. So I know my missing angle X is 28 degrees. We've seen parallel lines before, and just to remind you, parallel lines are two lines that are running in the same direction. Okay, typically parallel lines are marked by arrowheads to indicate the direction that they're running. We know that parallel lines will never cross each other, they will never meet, they will never intersect. So we can have a set of parallel lines. However, we can also then draw in a third line that is running through our set of parallel lines. And because it runs through them, they obviously intersect. So this line that I'm showing you on the screen here is what we call a transversal or a transversal line. By putting a transversal line through a set of parallel lines, we can create a whole bunch of different angles. And those are the angles that are marked here with these numbers. So what we're going to take a look at now are what we call angle theorems. Angle theorems are properties or relationships or patterns that we can see with angles, and they are created by putting in a transversal line through a set of parallel lines. The first theorem is the opposite angle theorem. Opposite angle theorem tells us that pairs of opposite angles are positioned across from each other when a transversal crosses one of the parallel lines. And so if we take a look at our little picture here, we can see that we have a set of parallel lines. We have a transversal running through them, and we've created all these tiny little angles here that are marked with lowercase letters. So when we're talking about opposite angles, we're talking about angles that are directly across from each other. So for example, that would be angle B and angle C. These two angles are across or opposite from each other. Same goes for angle A and angle D. Those are another set of opposite angles. We also have angle F and angle G, and angle E and angle H. So the opposite angle theorem tells us that opposite angles are equal to each other. So if we know that two angles are opposite from each other, we know that they have to have the same angle measure. So knowing that, we can then say that according to the picture that we have here, whatever angle A is, it's going to be equal to or exactly the same as angle D. Same goes for angle B and angle C, angle E and angle H, angle F and angle G. Any angles that are directly opposite from each other, they are going to be equal. Sometimes we can also call the opposite angle theorem the X pattern, and that's simply because angles that are opposite from each other, if we were to kind of highlight the lines along which they are found, kind of makes the shape of the letter X, like I've highlighted here. So for instance, if we're saying that angle B and angle C are opposite from each other, we know that they are equal to each other, and they kind of fall along a set of lines that makes kind of like an X shape. So let's try an example here. We're asked to find the unknown angles. So the unknown angles here are simply just the spaces that are left blank. We have to fill them in with angle measurements. We're asked to also justify our answer. Now, to justify our answer means to just explain. How do we know what the measurement will be for this angle and what the measurement will be for this angle? What kind of pattern or relationship or angle theorem are we using to figure out our angles? So in this diagram, there are actually two different angle theorems that I can use to prove or justify my answer. So there's a couple things that I see when I look at this diagram. So for instance, I know that this angle is 75 as it's marked for me, and there is an angle that is directly opposite to it. So knowing the opposite angle theorem, I know that this angle here at the bottom also needs to be 75 degrees. So I've gone ahead and filled that in. And in terms of my justification, I'm going to say that the angle is 75 degrees because of the opposite angle theorem. And you can even abbreviate this and shorten it down to OAT, which just stands for opposite angle theorem. So they've marked another angle for us. So they're telling us this angle here is 105 degrees. And again, there is an angle that is directly opposite from it. So I know that this angle here in the empty space also needs to be 105 degrees because these are opposite angles, and we know that opposite angles are equal. So I've gone ahead and filled that in as well. Now, we've used the opposite angle theorem to figure out the missing angles, but there is also another angle theorem that you could have used. Remember that this line here, for example, so the line that is marked C and A, so line CA is a straight line. And we learned previously that angles that are found on a straight line have to add up to 180 degrees. So knowing that, we can just do a little bit of a check here. 105 plus 75, these are two angles that were given to us. They are found on a straight line. They're found on this line segment BD, and together they add up to 180. So knowing that, I know that these two angles here are on the top. If this one was 75, this one wasn't given to us, we know that it's got to be a value or a number that would cause the entire total to add up to 180. So I could have also done 180 minus 75, and that would have also given me 105 degrees. Now, if we wanted to justify that or explain our answer, we could have just simply said that we know this because of the supplementary angle theorem, and that can be abbreviated down to SAT. Angle theorem number 2 is called the alternate angle theorem. Alternate angles are positioned on either side of the transversal between the parallel lines. Alternate angles are equal to each other, and they can be seen using what we call the Z pattern. So again, I have a set of parallel lines. I have a transversal line running through them, and that's created a bunch of different angles which are numbered for us. So we like to say that we can find alternate angles by using the Z pattern or the Z pattern. And what that means is you are looking for the letter Z or the letter Z in your diagram. So I'm going to highlight for you along the lines. And you can see that the portion that I'm kind of highlighting or shading with yellow resembles the letter Z. So the angles that fall along the Z that I've just outlined are angle 3 and angle 6. So those two angles, angle 3 and angle 6, they would be equal to each other, and we could state that they are alternate angles. So I've gone ahead and cleared out the diagram because you can also look for a backwards Z. So I'm going to highlight that pattern for you this time using a blue marker. So it doesn't look like a conventional Z, it's kind of flattened and slanted out, but this would also be considered a Z pattern. Okay, and so if we took a look at this type of pattern, then the angles that would be alternate angles to each other would be angle number 4 and angle number 5. So those are the angles that are attached to the Z or kind of in between the Z. So angle number 4 and angle number 5 would actually be equal to each other, and they would be considered alternate angles. Okay, so here's a brand new example for us. We're asked to determine all of the unknown angles, and we are supposed to justify our answer. So we have a bunch of angles that we need to figure out. We've got angle G, angle H, angle K, angle L, angle M, and angle N. So the only angles that we do know are angle I, which is 130 degrees, and angle J, which is 50 degrees. The good thing about doing questions like this is there are numerous different ways that you can come up with the answer. Not everybody is going to use the exact same theorems or relationships in the exact same order, and that's okay. As long as you are able to justify your answer and how you came up with the angle measurement, the answer will still be correct. So as I go through each angle, you might be doing it on your own, and you might, find the angles in a different order or use different relationships to come up with the angles, but know that that is okay. So we're actually going to use a combination of lots of different patterns and theorems. You are not confined to just using one type of angle theorem. So let's start off with angle G up on the top here. So what I know is that angle G is opposite to angle J. And because I know angle J is 50, remember that opposite angles are equal to each other. So if angle J is 50, that means angle G also has to be 50 degrees. So I'm going to go ahead and fill that in here. And my justification, again, is because I know that these angles are opposite angles. So let's move on to find angle H. So I know that angle H is directly opposite to angle I. So because angle I is marked for us, it's 130 degrees, that means that angle H also has to be 130 degrees. Okay, if we want to check and make sure that those values are correct, okay, remember that this line segment here, AB, this is a straight line, and any angles that fall along this straight line, they need to add up to 180 degrees. They need to be supplementary. So if I take my answers of 50 and 130 and I add them together, they should add up to 180. And 50 plus 130 is indeed 180 degrees. So I know that my answers are correct. Not only are these opposite angles to I and J, but they are also supplementary angles. So angle I and angle G, they fall on a straight line, so they should be supplementary, and 130 plus 50 is indeed 180. Same goes for H and J. They fall along a straight line as well, just on the opposite side. And 130 plus 50 is again also 180 degrees. Let's move to the bottom half of our diagram, and we'll start by trying to figure out angles K and L. So if I take a look at my picture, I do see that there are some alternate angles. Now, it may not look like a perfect Z pattern, but I'm going to highlight it out for you. And so this is a Z pattern that I see in my picture. So knowing that, that tells me that within this Z pattern, that means that angle I, which is 130 degrees, is going to be equal to angle L. Angle I and angle L are alternate angles. So that means that angle L is going to be 130 degrees. So in terms of the justification that I'm going to give here, I'm going to say that angle I and angle L are alternate angles. Okay, what about finding angle K? So I see that there is another Z pattern within my diagram, which I'm highlighting for you in yellow. Highlighted Z pattern, I can see that angle J, which is 50 degrees, is going to be equal to angle K. They are alternate angles. So I've gone ahead and filled in that K is 50 degrees. And if you wanted to give your justification, you would say that angles J and K are alternate angles. So I went ahead and filled in all of the other justifications as well, so you can remember how we came up with those answers. The last two angles that we need to figure out are the bottom angles, which are angle M and angle N. Okay, and again, you can use one of two different methods or theorems. Okay, I know that angle L, which is 130, is opposite from angle M, and I know that opposite angles have to be equal. So if angle L is 130, that means angle M is also going to be 130 degrees. And same goes for angle N. I know that if angle K is 50 degrees, it is directly opposite to angle N. Opposite angles are equal, which tells me that angle N also has to be 50 degrees. And I've gone ahead and filled in the justifications for angle M and angle N. I said that I know there is an opposite angle theorem, or OAT, between angle L and angle M. That's how we got the 130 degrees. And I also know that there's an opposite angle theorem, or OAT, between angle K and angle N. So both of those angles had to be 50 degrees. Angle theorem number 3 is the corresponding angle theorem. Corresponding angles are located in what we call corresponding positions relative to the transversal and parallel lines. corresponding angles are equal. Now, in terms of figuring out the corresponding positions, we are going to look for something that we call the F pattern. So I've zoomed in a little closer to our diagram. So again, we have our set of parallel lines, our transversal running through it, and our numbered angles. So if we're looking for the F pattern, you're looking for what could resemble the letter F. So I'm going to highlight it out for you. Here is one potential F pattern. So you can see that there is a kind of flattened out, slanted looking letter F. And in terms of the angles that would be considered corresponding angles, that would be angle number 4, so kind of in the inner top corner of the F, and angle number 8 in the bottom kind of tucked in corner of the F. So angle 4 and angle 8, they would be equal to each other. So whatever measurement we'd have, let's say for angle 4, it would be the same angle measurement for angle 8 or vice versa. So these are considered to be corresponding positions. And so that's what tells us that angles 4 and 8 would be corresponding angles. Now remember, you can also have a backwards F. So I'm going to highlight that for you in blue. And here it is. So again, looking kind of slanted and flattened out, but this is a backwards F. So in terms of the corresponding angles here, angle number 3, again in kind of like the top inner corner, that would be equal to angle number 7. So kind of in that bottom inner corner. So angle 3 and angle 7 are considered to be corresponding angles, and they would be equal to each other. So I just wanted to take note of those angles that we just talked about. So we said that angle number 4 is corresponding or equal to angle number 8, and angle number 3 is corresponding or equal to angle number 7. So I've gone back to my diagram because there actually are a couple of other corresponding angles in this diagram. And that's sometimes what the tricky thing can be with for the corresponding angles, is because students don't always see all of the potential F patterns that they can find in their diagram. So we looked at the two main ones, so a regular F and then a backwards F, but there are two other ones that we can actually highlight. So here is the third one. It is kind of upside down looking, but this is also considered an F. So it's almost like it is turned upside down and in the opposite direction. So if we were to look at this kind of wonky looking F pattern, the angles that would be corresponding to each other would be angle number 6, so again in this kind of tucked in inner corner, and angle number 2. So those two angles would be corresponding angles, and they would be equal to each other. So whatever angle 6 is, it's the same angle that's going to show up in the position of angle number 2. The last pattern that we can find is we're going to go again down the middle kind of. And then here are the branches for the F. So it's kind of again turned upside down and on the other side. So there's the F pattern, and then in terms of which angles are corresponding, it would be angle number 5 and angle number 1. So these two angles are going to be corresponding, and they would be equal to each other. So I've added those last two corresponding angle pairs to our list. And again, if you kind of want to see, we said that angle number 4 was the same as angle number 8, so they're corresponding and equal. Angle number 3 was corresponding and equal to angle number 7. We said angle 6 was corresponding and equal to angle number 2. And angle number 5 matches up to angle number 1. So you can kind of see it's kind of like an every other type of situation. So for example, if you're focusing on number 2, you would skip the angle directly beside it, and the matching angle would be angle number 6. So there is kind of a visible pattern that you can see here. Okay, so we have another example that we're going to work with. We're going to determine all of the unknown angles, and we're going to justify our answers. So now we have like a whole bunch of different angle theorems that we can work with. We have supplementary angles. We are not going to use corresponding angles here because none of these angles marked are 90 degrees. We have no little squares marked in any of the corners. So if we don't see a square, we're not going to assume that any of these are 90 degrees, so we're not going to be using the corresponding angle theorem at all. So we do have supplementary angle theorem, we have the opposite angle theorem, we have the alternate angle theorem, so those are the angles marked by the Z pattern, and now we have the corresponding angle theorem to add into the mix. So that's the F patterns that we just looked at. So like I said, you might use a whole bunch of different angle theorems, and then another student or classmate might only use 2 angle theorems and get the exact same answers. So there is no one right way to do this, and that's kind of like the beauty of these types of angle questions. So it doesn't matter where we start. I'm going to start at the top, and if I know that this angle marked here is 40 degrees, okay, I can see from my diagram that angle F is located directly across or opposite to the 40-degree angle. So that tells me right away that I do know that angle F is 40 degrees. So I'm going to go ahead and fill that in. And then out here on the side, I'm just going to keep a list of all of my justifications. So we know that angle F is 40 degrees. And for my justification, I'm going to say opposite angle theorem, so OAT. And I need to say what it is opposite to. So I'm going to say opposite angle theorem with, let me zoom out a little bit here. So opposite angle theorem with the other 40-degree angle. Okay, going back to my diagram, I don't like to jump around a lot. I like to kind of focus in on one area and solve one area at a time. It's totally up to you. If you want to go in first and just fill in all of the things that you can immediately fill in, that's fine. But I'm going to stay in this corner and try to figure out angle G and angle H first before I move on. So I know that angle F is 40. Let's just go alphabetically. So let's try to figure out what angle G would be. So there's a couple ways we could look at it. We could look at the angle G, which is beside angle F, or we could look at angle G, which is also beside this 40-degree angle, which was marked for us. Either way, it's going to give us the same answer. So what I do know, for example, is that angle G and this 40-degree angle, they are on this completely straight line here. It's actually line segment EL. And I know that angles on a straight line are supplementary. They are supposed to add up to 180 degrees, and they are directly beside each other. So that means in order to find angle G, I can just simply take 180 degrees and subtract 40 degrees. The leftover, it has to be the angle value for angle G. So I'm going to just fill that in here. 180 minus 40 is 140 degrees. So going back to my list that I'm keeping, I'm going to say angle G is equal to 140 degrees. And my justification is that I used the supplementary angle theorem, again, with the 40-degree angle that was already given to me. So I know that angle G and that 40-degree angle had to be supplementary to each other. Okay, so the last angle that we need to figure out in this upper section would be angle H. Now, this is nice and simple because I know that angle G and angle H, they're opposite from each other, and I know that opposite angles are equal. So if angle G is 140 degrees, that means that angle H also has to be 140 degrees. Another way that we could figure this out is we know that angle F and angle H, they are supplementary to each other. They are beside each other on a completely straight line, which means that together they need to add up to 180 degrees. So if angle F is 40, well then I know 180 minus 40 also again has to be 140 degrees. So same exact angle measurement as angle G. So there are two justifications that you can possibly give for angle H. Doesn't matter which one you provide. You don't have to provide both. You're just going to give the one that you used to figure out angle H. So I'm going to fill that in my picture. So this is 140 degrees. And then I'm going to go over to my list and I'm going to say angle H is equal to 140. And I used initially the opposite angle theorem, and I know that it is opposite angles with angle G. Okay, so now it's time to move on to this kind of bottom portion. And in our bottom half of our diagram, we have angle I, angle J, and angle K to figure out. So the easiest one to start with would actually be angle J, if you really wanted to start here, because I know that angle J is opposite to this 140 degree angle. So I know opposite angles are equal, so angle J we are going to fill in as 140 degrees. Okay, so if I go to my list, I'm going to say angle J is equal to 140 degrees, and my justification is that I use the opposite angle theorem with the 140 degree angle that was already given to us. Okay, so we have two more left. Let's actually look at angle I. So we know that angle I is directly beside this 140 degree angle. So because of that, I know that these two angles are supplementary. They are two angles that are side by side on a straight line. They have to add up to 180. So 180 minus 140, I'm going to do this over here. So I know 180 minus 140 is actually going to be 40 degrees. So angle I is going to be 40 degrees. Another way that you could also figure out angle I is to use the alternate angle theorem, or think of it as a Z pattern. So it's kind of hard to see with our entire diagram kind of slanted this way, but if you were to take your piece of paper or your screen and rotate it, you can actually see that there is a Z pattern here, which I'm going to shade in for you in green. There is a Z here. So with that Z pattern, I can very clearly see that if this corner angle is 40, that means the angle with angle I also has to be 40 degrees. Those two angles are alternate angles. So if we go back over to our list, we know that angle I is 40 degrees. Now, originally our justification that we used was that it was a supplementary angle with the 140 degree angle that was marked. So I used the supplementary angle theorem, or SAT. But again, if you really wanted to use the alternate angle theorem, then you would simply just say that you know that angle I is 40 degrees because it was alternate angles with that marked 40 degrees from the diagram. Okay, the last angle that we need to figure out is angle K, and again, there are two ways that we could do this. We know that angle J, which is 140, and angle K, these two angles are beside each other on a straight line. They again have to be supplementary. You could also look at it this way. This angle here is 140. It is directly beside angle K. These two angles are on this straight line segment, CD. So again, these two angles have to add up to 180 degrees. So knowing that, I can say that 180 minus 140 is 40 degrees. So angle K is going to be 40 degrees. Again, another way that you could figure this out, which would also be correct, if you know that angle I is 40 degrees, it is directly opposite to angle K. So they have to be the same. So if angle I is 40, then angle K also is going to be 40 degrees. So we could use the supplementary angle theorem, or you could use the opposite angle theorem. Okay, another way that you could also figure out angle K uses corresponding angles, or the F pattern. So it is kind of hard to see when it's not directly in front of you, plus our diagram is kind of rotated a little bit, but I've highlighted it here for you in yellow. So you can see that there is this backwards kind of sideways F. And so if we were to use this, okay, and use the F pattern, our corresponding angles would be this 40-degree angle in the corner and angle K. So that tells us then that if this angle is 40 degrees, that means that angle K is also going to be 40 degrees. And we know for a fact that it is from our previous calculations. So not only could you use supplementary angle theorem, you could also use the opposite angle theorem, or you could also use the corresponding angle theorem. So to close off our list, we can say that angle K is 40 degrees, and there were 3 different reasons that you could possibly give. You could say supplementary angles, for example, with angle J. It could have been the opposite angle theorem with angle I, or you could say that there were corresponding angles between K and that marked 40-degree angle. The fourth and final angle theorem is the co-interior angle theorem. Co-interior angles are in the same interior regions formed by the parallel lines and the transversal line. We say that we can identify co-interior angles from our diagram using what we call the C pattern. Now, unlike the other patterns that we've talked about in this video, where the angles were always equal to each other, co-interior angles are not equal to each other. Instead, once you find your pair of co-interior angles, those 2 angles will actually add up to 180 degrees. So let's take a look a little bit closer at the diagram that we have here. And so I'm going to mark for you 2 possible C patterns in this particular diagram. So we can have a regular looking C. So here is a letter C. It's kind of a boxy looking letter C. So the angles that are inside this C pattern, or the co-interior angles, those angles would be angle C and angle E. So they are kind of like the inner corners of the letter C that is highlighted in yellow. So together, angle C plus angle E should add up to 180 degrees. You could also have a backwards looking C pattern. So for example, if I highlighted for you a backwards C, it would be located here in blue. So this is a backwards C pattern, and the co-interior angles in this one would be angle D and angle F. So the inner corners of the backwards C pattern. So together, angle D plus angle F should add up to 180 degrees. So here is our final example. We need to determine the unknown angles. So we've got angle X, angle Y, and angle Z. And again, we're going to justify our answers. So if I go in a little bit closer, the first thing I notice is that I have a C pattern. So there is a C in my diagram located where I'm highlighting in yellow. So that tells me that this 58-degree angle plus angle Z, together they should add up to 180. So I'm going to do this math right in my diagram. So 180 minus 58 is 122 degrees. So if I kind of keep a list, I can say that angle Z is equal to 122 degrees. And the reason why I know this is because this is a co-interior angle with that marked 58-degree angle. So again, with these angle questions, there are so many different ways that you can come up with your answers, and there's a whole mixture or combination of theorems that you can use. So how you might choose to approach finding angles x and y might be a little bit different than how I'm going to do it, but just know that we can totally get the same answer. So I'm going to use my information in this diagram, and I can see that there is a Z pattern right here, which I'm highlighting in green. So what that tells me is that angle X and angle Z are alternate angles. So that means that if I know that angle Z is 122 degrees, that means angle X is also going to be 122 degrees. They are alternate angles. So I went ahead and put that into my list. So I said angle X is equal to 122 degrees. And I know this, or my justification is because it is an alternate angle to angle Z. So the last angle to determine would be angle Y. And what I can see in this picture is that there is a backwards C pattern right here. So what that tells me is that angle X and angle Y, they are co-interior angles. So angle X plus angle Y should add up to 180 degrees. So if I were to do a simple subtraction, let's make this a little bit bigger. So I know that 180 minus 122, that's going to give me angle Y, and that would be equal to 58 degrees. So angle Y is equal to 58 degrees. And for my justification, I've stated that I know angle Y is 58 degrees because it is a co-interior angle with angle X. So as you can see, there are lots of different patterns and relationships which create the different angle theorems that we can use to solve for angles. Now, all of the angles that are created in these diagrams occur because of a transversal line running or intersecting between or through a set of parallel lines. Remember that there are a variety of ways that you can get your answers as long as you are able to provide a proper justification using the correct terminology for the angle theorems.